Hello everyone. Today in this video, we are discussing about DBMS fourth module, transaction processing. So, will let us know what are the objectives of the transaction processing. First, the main point is to study the transaction properties, to study set time of schedule and maintaining scheduling equivalence, to check whether a given schedule is serializable or not, to study protocols used for looking objectives, differentiating between 2PL and strict 2PL. Let's start with the introduction to transaction processing. So, what is transaction processing? So, it is about single users and multiple user systems. On that criterion only, we are classifying with database the where that on a criterion of classifying a database system is according to the number of users who can use a system concurrently. Means how many systems are using concurrently. On that basis we are going to classify use the system as a single users or a multiple users. Let us know what is single user and multi users. What is single user now? At most, one user at a time can use the system. That is called single users. Nothing but example for your personal computer or PC, laptops, anything. So you are the only one person using that system at a time. So that is called as single users. Let's know about multiple users. What are multiple users or multi users? Many users can use the system and hence access the database concurrently, so that for a single system many users can access that system from a particular place or anywhere. Okay, for example, airline reservation database. For example, here is a airline reservation database. So here you can access the airline reservation from anywhere, or anyone can access the reservation process. So the next topic is transactions. What is transactions now? A transaction is a sequence of database operations what are treated as a single logical unit at work. Okay. So a transaction is a sequence of database operation. It is a sequence of database operations that are treated as a single logical unit at work. The transaction must satisfy ACID properties. It's nothing but these are the properties also, and this should satisfy by the transaction. So you can call it as a transaction. First one is automaticity, consistency, isolation, durability. We'll discuss about it later in upcoming topics. So next, the second one is database items. What is a database items? A database item refers to a piece of data stored in a database. It can be of an entire row or entire column value, a block or a page, an individual field. These items access and modified by transactions. Okay. Next, we have read and write operations. What are read and write operations? We have studied previously. Transaction access database items using read, which nothing but reads the value of item X. If the item is X, it will read the value of that item from the database. Okay, it will read the value of the item from the database. Next, write operation. What this operation will do? Write operation is writes a new value to item. Okay, new value to item X, which is nothing but you have item X, it's write the new value for that item. Next, we have operations are successfully logged and buffered to ensure the recovery and concurrency of the control. So that operations are usually logged. Okay, so you should log the operations for the insurance of recovery and concurrency of the control. Next, DBMS buffers. What does this DBMS buffers mean? The DBMS buffers is an in-memory area where database pages are cached to minimize disk input device. Okay, you can call it as disk input device. IO is nothing but input device. The DBMS buffer is an in-memory area where database pages were cached to minimize the disk input. Okay, input and output. Okay, how it works? Let's see how it works. When a page is read, it's loaded into a buffer, then it writes happen to the buffer first, then are flushed to the disk based on the policies like write hide, logging, or least recently used, that is LRU. Okay, buffers improve the performance by reducing the need of slow disk access. This is about that. Then why we need of that concurrency control is needed. Why is there is a concurrency needed? Okay, we'll study about that. So we have 5 points or four. We have 4 points here. First one is the lost update problem, the update temporary update problem, or the incurrent summary problem, and the unrepeatable read problem. Okay, these are the four concurrency controls measures should be needed. This is why the concurrency is needed. Okay, the first one is about, we'll study that one. Will failures. What are the types of failures? This types of failures. There's a first one is a computer failure. Is nothing but what is the computer failing means? It's a system crash. Is nothing but a system crash. Oh, okay. A computer failure refers to a hardware of a software network error occurs in the computer system during the transaction execution. Is nothing but a computer failure. What is a computer failure means? A hardware or software or a network errors occurs in the computer during transaction. While you are doing transaction execution, a system error will occur. That is called as computer failure. It is a one of the failure. Okay. Next one is a transaction or system failure. Okay. System failure, or you can call it a system error also. Some operation in the transaction may cause it to fail, such as integer or follow or division by zero. So while doing a program, so you will got up with many errors. In that, integer overflow and the division by zero are some errors. So this transaction may cause the transactions or a system error. This is caused by the system. Okay. This also it occurs because parameter values also in the it occurs in during the parameters value. While giving the parameters value, it takes some high or minimum like that value it will takes. Next one is local errors and exceptions. Okay, during transition execution, certain condition may occur that is necessary cancellations of the transaction. So some transaction are required where many transaction will be there. So you should delete something there. Okay, if you are not canceling that, you cannot install new things there. So this is the type of a failure it is occurring. Next one is concurrency control and enforcement. So, what does this mean by concurrency control and enforcement? The concurrency control may decide to abort a transaction because it it involves or several transactions are in state of deadlock. Okay, concurrency control enforcement with nothing but in the state of deadlock, several transactions are attract or attached. Okay, this may cause the types of failure is one of failure. Next, we are moving to disk failure. What is meant by this disk failure? Some disk blocks may lose their data because of read or write malfunctions or because of a disk read and write head crash. Okay, this may cause disk failure. Next, physical problems. Okay, what are those physical problems? Refers to endless list of problems that includes power or air conditioning failure, fire, theft, overwriting disk, or taps by mistakes. Okay, it done the failures by mistakes. Okay, if you a person is touching that hard disk, so it may damage that, or else any fire attacks will be happen. Likewise, it will happen. Okay, next we have transaction states and additional operations. Okay, we have transaction states and additional operations. First, we need to know about what is the transaction here. Okay, a transaction goes through a finite set of states during its life cycle. Okay, it goes finite set of states during its life cycle. Understanding these states in critical of managing concurrency and recovery. First one is active. Second one is partially committed, and the others were all there. We'll see about active there. A transaction is executing its operations with nothing but read and write. Next one, it can still fail to complete normally. It will still completely normally, or it cannot possible. Okay. Next, partially committed. All operations have been executed successfully, but changes are not yet permanent. The changes will not yet permanent while their execution is successful, but the changes are not yet permanent. Okay, they are still under okay something. It waiting to be committed to the database. Okay, it's waiting to be committed. Okay, to the database. Next, we have committed. Okay, what is meant by this commit? You're doing programs, you'll commit to that. Okay, what is the meaning of that commit statement there? It's nothing but what you have done till now, you should commit it. Means it is a saving procedure. Okay, the transaction has been complete successfully. Okay, all changes are permanent and will survive in the system crash. Okay, next one is failed. An error occurred. Okay, fail is nothing but you are failing something. Okay, that nothing but you are an error is occurred. A transaction can no longer proceed. Next one is aborted. A transaction is rolled back to undo changes. After aborting, it may restarted or terminated. Next, we have the block diagram. First, the active statements will occur, then this active will occur, then the others will going down. The look after the black block diagram. Next, what are the additional operation in the transactions? Is there operations? First one is the begin operation. It starts a transaction. Second one is the read operations. It reads the value of item. Write operation writes the value of item. Commit operations. It saves the changes permanently. And we have rollback, cancels and undoes the changes. Next, save point sets the checkpoint within a transaction. Roll back to roll back to a specific save point. These are all the additional operations in the transactions. You should study it, and exam point of view is very important. Next, already discussed about what are ACID properties is nothing but if a transaction is occurring, it should satisfy these all four conditions. These are also called ACID properties. Okay, first A, what is the A stands for? A stands for atomicity, C stands for consistency, whereas I stands for isolation, D is nothing but durability. What is this atomicity? A transaction is an atomic unit of processing and it is either performed entirely or not at all. It's nothing but a transaction is an atomic unit of processing and it is there either performed entity or not at all. Next, what is this consistency preservations? A transaction should be consistent preserving that it is must take the database from a consistent state or another state. Nothing but if you are saying to a one consistent system, it should share it to the another system. Okay, it will be like that, so it will be consistent. Okay, next one is isolation or independence. A transaction should appear through it is being executed in an isolation from other transaction, even though many transactions exist executed concurrently. Is nothing but while running other programs, other transactions. Okay, this should work or execute independently. So, which does not distract with the other transactions. Okay. Next one is durability. If a transaction changes the database and is committed, the changes must never lost because of any failure. Durability is nothing but permanency. They are mentioned permanency. Permanency is nothing but what the thing is permanent. We cannot avoid it. Okay, that is the thing. Okay, the sun example, the sun is permanent. Nothing but the sun will rise early in the morning. It will not change. Likewise, if it's once committed in the transaction, it will never changes. Okay. Next, this is about the transactions. Okay, transactions in the database model system, the DBMS fourth module. So, thank you.